And this is Unit 5, Lesson 2, Part 2. We're going to be starting by talking about something called turning points. So the definition right here, these are the point or points at which a polynomial switches direction. So you can see a point like this one right here, or a point like this one right here. The direction, the graph is going up or it's increasing, and then right here it switches direction, starts going down or decreasing, and then it switches direction again and starts increasing. So these are considered to be turning points because the direction of the graph changes there. If the turning point is higher than any other nearby point, it is called a relative maximum, or just a max, as you'll probably hear me say. If the turning point is lower than any nearby point, it is called a relative minimum. Or again, you'll probably just hear me say min. So this point right here is considered to be a relative maximum point. This point right here is considered to be a relative minimum point. Now, not the highest or lowest point ever, but just like it said, higher than any other nearby point. So kind of like a little peak or a hill in the graph. This is like a little valley in the graph. And we call maximum and minimum values, we call those extrema. Okay, and then like I was saying here, they define where the function is increasing or decreasing. So this one was increasing until this point, then decreasing, and then increasing after. So we're going to use that as we're talking about some different characteristics of these polynomials. So we are going to use a calculator. We're actually going to use Desmos to find the turning point. So kind of ignore these directions right here, and I am just going to write down here that we will be using Desmos, because it is unfair to assume that you guys are all using the very same, like TI-83 or 84. Chances are you're not, but we all have iPads, we all have Desmos. So I'm going to teach you guys, starting with number 1, how we are going to use Desmos to find our maxes and mins, our turning points. So our directions right here, we're going to graph. We're not going to graph using a table. We are just going to plug everything into our calculator. So take this f of x. You don't have to type the f of x, you just write this part of it right here. So we're going to type in negative x to the third plus 3x squared. Okay, so that is our graph. I'm going to make sure this is bold enough that you guys can see it. So this is the shape of our graph, and I want to show you a really cool little feature that Desmos has. If you click on the graph, like kind of tap it like this, see how a couple different points show up right here? You guys, if you do this along with me, you should be able to see these little gray dots that pop up. I want you to click on any points that they give you, because that'll be just more information that you can put on your graph. So I'm going to plot these 3 points. So 0, 0 is right at the origin here, and then we had 2, 4, which is right here, and then we also had the point, if you can see it right here, 3, 0. So 3, 0 is right here on the x-axis. So just those points, not enough to actually see what the graph looks like, but when you see the shape, we can kind of connect the dots, and you can zoom in, zoom out, see if there are any other turning points, and even if you zoom out, it's not turning around again over here or over here. It has these 2 turning points, which we labeled. So you can just give a sketch like this of what this graph looks like. That's what we're looking for. So you want to especially see the turning points. So now that we see that graph in front of us, let's write down all of this information right here. So this is the stuff, it's going to take some practice to learn how to write all these things down. So domain. Domain, remember, is all of the possible x values. Any polynomial that you're graphing, it's going to be all reals for the domain, because there's no restriction on what you're allowed to plug in. You're allowed to plug in any x value that you want, so it's always going to be all reals. Also, a way to think of it is the domain is x's, and x's go left and right. This arrow, if we keep graphing, it keeps going to the left. It's going slowly, but it'll keep going to the left forever. This arrow will keep going to the right forever. So there will never be a lowest or highest x value. They just keep on going. The range is the y values, so you want to look up and down. We did this with absolute value already in the last unit and with quadratics. So you want to look, is there a maximum point? Is there a minimum point? This arrow keeps going up forever. This arrow keeps going down forever. The y values never stop. So the y values are also going to be all reals. So that's the domain and range. Next thing we want to write down is any relative maximum points, any relative minimum points. So relative maximums are anything that look kind of like this on our graph. And that would be this point right there. So I want to remind you, on Desmos, you can tap and get the actual ordered pair. And that's what we're looking for when we fill this out. We want the ordered pair. So that would be 2, 4 is our maximum point. And then the relative minimum is this little valley in the graph right here where it's going down, turns around, and then goes up. And that is right at the origin. So our minimum point is 0, 0. Okay, so I'm going to label those on this graph really quickly. 0, 0, and 2, 4, just so I don't have to keep putting Desmos back up on the screen. I can just use this graph. So end behavior, this is something that we talked about recently. We are looking at the two ends of the graph. So remember, as x approaches infinity, that is the right edge of the graph. So as we move over in this direction, there is an arrow, and that arrow is going down. So we say the function values, if they're going down, they are approaching negative infinity. So this means the right arrow of the graph is headed down. That's how we kind of unpack these infinity statements. This says as x approaches negative infinity, so that's the left end of the graph. The left end of the graph is marked by this arrow here. This arrow is going up. So we say the function values approach positive infinity, which means they just keep getting bigger and bigger. They just keep going up. Last thing we're going to write down is increasing and decreasing intervals. This part's a little bit tricky. So we want to go in terms of x's. Okay, so with increasing and decreasing intervals, we are writing x values. And I want you guys to make yourself a little note there in case you get confused about what these mean. So these are going to be intervals of x values. At what x value does it begin to increase? At what value does it stop increasing? So it only increases on this little segment of the graph right here. So it begins to increase when x is 0, and it stops increasing when x is 2. So we write 0, 2. This is like interval notation that you guys did way back in Unit 1. So this is the beginning and this is the end. The graph starts to increase when x is 0. The graph stops increasing and turns around when x is 2. Decreasing intervals, we actually have two separate intervals because it's decreasing here and then it's decreasing again right here. Because of this arrow, it never really starts decreasing. The left end of the graph is decreasing, and the left end we consider to be an x value of negative infinity. So it never really starts, just all the way to the left, it's decreasing, and then it decreases until it hits this x value, which is 0. So the graph decreases from the left arrow until we get to an x coordinate of 0. Then it switches to increasing, then we come back to decreasing again. So we put this little union symbol. So always going left to right, it starts decreasing here, which is an x value of 2, and then it decreases forever. So when it ends in this right arrow, the right arrow we consider to be positive infinity for x. So those are our increasing and decreasing intervals. That's probably the trickiest part. That'll take a little while to wrap our heads around. We're going to do one more on the next page. We're going to do number 3. So just like before, I want to plug that into Desmos so I can get all the important points. So I'm going to clear out the one I had in here before. I'm going to graph negative x to the 4th plus 4x squared minus 3x minus 2. So feel free to open Desmos on the side of your screen as well so you guys can plug in these points, see what they look like. So I'm going to zoom out a little bit. We've got these points, peaks and valleys, so I have a bunch of points right here. I'm going to click on all of these, and then I can plot these on my graph. All right, so there are lots of them here, so I'm going to go kind of one at a time. So this point right here is just to the left of negative 2. It's right on the x-axis. So this just a little bit past the negative 2 right here. And then we've got this point right here. So these are not going to be nice, neat points like the last one had. So negative 1.5 and then about 6.5. So negative 1.5, and then we can go up 3, 4, 5, 6.5. So it's kind of right in the middle of that grid. It's hard to see. Next, we hit the x-axis again right here, just about negative 1/2. So we're going to go right about here. We just want enough that we can see the shape of this graph. Then we have a y-intercept. The y-intercept is right nice and neat at negative 2. So that's this point right here. Then we've got a little valley in our graph. This is negative 0.4 and then about negative 2.5. So about 1/2 and then negative 2.5. So we go over 1/2 and then about negative 2.5, kind of right in the middle of that grid. Here's another turning point, just past 1 and then almost to -2. So just past 1 and then almost to -2 would be like kind of right in the corner of that grid. And then it just goes down from there. So if we kind of match what we've got here, we want to hit all these points. It goes up, goes down, up again, and then it just goes down after that. So that is our graph, kind of a strange looking shape. Remember, a negative even means the arrow's going the same direction, and the negative means they're both going down. So let's write domain and range. Every polynomial has a domain of all reals. That's never going to change. The range for this one, you're looking for whether it goes up forever, it goes down forever. This goes down forever, but this actually is our very highest y value. It never goes beyond this point. So we can say that y is less than or equal to whatever this y value is, and that's why having these little points on Desmos can come in handy. It's this y value, 6.494, and you do want to make sure that you're being exact. Okay, so we've got that. That is our range. Our relative maximum and minimum points. So starting with the maximums, these two that I have clicked right here, these are like the little peaks of the graph. So I'm going to write down those ordered pairs, write them small. -1.574 and 6.494 for y. And then we have another one, 1.164 for x and -1.908 for y. So those are like the little peaks on your graph. And then relative minimum is just this little valley of the graph right here. It's going down, turns around for just a second. So that is a minimum point, like a little valley on the graph. So we're going to be doing a lot of Desmos work in this section. All right, our end behavior. We can look at our graph here. Remember, as x approaches infinity, that is the right end of the graph. So look what the right side's doing. That's this side right here. That arrow is going down. So we say the function approaches negative infinity whenever the arrow goes down. And then as x approaches negative infinity, that is the left end of the graph. Because remember, x means left and right. This is right, this is left. The left arrow is also going down, so we say negative infinity. And this is what you guys had for even negative functions a couple lessons ago as well. Finally, our increasing intervals. So it increases in this first portion of the graph right here. So it starts at our left arrow, which means we start it with a negative infinity, and it increases until I get to this x value right here, which let's go back to our graph. This x value is -1.574. Then it switches to decreasing, and then it increases just for this tiny little bit right here. So I'm going to write x value to x value of this next little increasing portion. So it starts increasing this little point right here. So we write down that x value, 0.409, up until the next x value, which is this, 1.164. Okay, so then decreasing intervals is the other parts. So it decreases from this x value right here down to this x value right here. So remember, this x value is the same as this one, -1.574, comma, and then it decreases till it gets to this little valley, which is 0.409. Okay, so that's the first time it's decreasing. Then it decreases again from this point. Oops, that's not even on the screen, I'm sorry. Decreases from this point forever. So we find this point right here, which is 1.164. And then it just decreases forever. When it ends in a right arrow, we just say positive infinity. So the decreasing, increasing will take a little while. Just take some practice.